Morning, everybody. We'll be getting started in a minute or two. Just give the last few people a chance to get in. So today we'll be going through the answers for lesson 8, which was all about using files, so reading and writing to files. Okay, let's get started with these first few questions. I think I saw on Tuesday's lesson that most people had actually managed to get these done during the lesson, so they're the more simple form of the questions. So the important thing for all of session 8's questions is that you have to have forked from a repo that Saf will have sent you. So hopefully Saf is listening in the chat now and can just paste the URL in. But basically what this does is we've already pre-made a bunch of text files, and then all of these questions reference those text files. So the first thing that you always need to do with this lesson's questions is just make sure that you actually have those text files available, otherwise none of your answers will work. So Saf's just pasted it in there, so you click on that REPL link and at the top of the screen there should be a little button called fork. You would press that and it then creates your own little REPL, and it contains all the different files that we use during today's lesson or answers. So without further ado, let's jump over into REPL and get started on the first answer. So the first question was to read the file jabberwocky.txt and then print out the content to the screen. So the first thing that we always have to do when dealing with files is to open it. So for this, we use the open function. So you use open followed by the name of the file. And this is probably the hardest part of this, is making sure that you name the file correctly. So make a note here that I'm using the name of the file plus the extension of the file. So you'll need both of them to be able to direct Python to the exact file that you're referring to. And then the next thing that you need to do with the open function is pass in, I guess, the way that you want to open the file. So since we're only reading this file, we can pass in the R character, which is just short for reading. So what open does is it returns a pointer to the file. So we're going to store that in a variable. So I think on the examples on Tuesday, we were just using f. So in the variable f, we are storing now the open file of jabberwocky.txt. So we'll just start seeing here if that's working. So again, I'm just going to do a print statement on f and we'll see what happens. So as you can see, it's printing some information. It sort of looks a little like gibberish. But this is just pointing out here that we've opened a file, it's got the file name, and this is the mode that it's in. So the file mode is reading, and then this is an encoding character set, which we don't really have to worry about too much, but it shows now that we've successfully opened the file. So our code is working. And the simplest way to solve this this question is we can actually just use the read function that is provided. So you can just say f.read, we'll run that again, and as you can see now it prints out the entire content of the file. So I can just double check that that is the case. I'm going to go on the left hand side. I don't think you can quite see it on the screen, but I'm going to open up the jabberwocky.txt file. This is the content of it. So it's 35 lines of this poem, and when we printed that out, or when we ran the program, those lines were shown on the right hand side. So that's the basic bit of code that you would need to read content from a file. So that answers question 1. So as always, I'll comment this out. So command / or control /. You can do multiple line comments, and we'll jump on to question 2. So question 2, we're going to read the file austen.txt. So again, pay attention here. We just want to read the file. So again, the file mode will just be R, and then we want to print out the number of lines in the file. Okay, so let's start off by, again, opening the file. So open, brackets, the name of the file. So in this case, it is austen.txt, the mode that we're opening it in, so we're just reading it. And then we want to now figure out the number of lines in it. So a way that we can do this is by creating sort of a temporary count variable. So let's create a variable called count. We'll set it to 0, and then we're going to loop through each line in the file. So I'm just going to say for, let's say, line in F. We'll go through, and every time we loop through, we're going to say that it's count plus equals 1. So the for statement here is going to loop through for each line of the file, and then the only action that we're going to take as part of that for loop is to increment a variable that we started off at 0. So this just means that by the time that this for loop completely finishes, the count variable will contain the number of lines in the file. So I'm just going to print that out at the end. We'll run the code and we'll see what happens. So it's saying 67 at the bottom there. So let me come down to the actual file and we'll just double check. And yep, the last line in the file is line 67. So here we've sort of confirmed that our code is working. And yeah, that's how you can count the number of lines in the file. There are, again, other ways that you can do that, but that's quite a nice way just to do it. So let's jump on to question 3. So each line of the file numbers.txt contains a number. Write a script to add up all the values in the file. So let's just have a look now at the numbers.txt to see what we're dealing with. So it's a bunch of numbers. They look like they go from a couple of hundred to a few thousand. So it's a load of numbers, and by the looks of it, there are 5,000 numbers in this file. So obviously you could go through and count them by hand, but this is a task that obviously programming sort of shines at. It's going to go through and just add up all of these values. So let's go through. So the first thing, again, we're always going to do is we're going to open the file. Again, we're not doing any writing here, so we only need to open it in read mode. So we'll do the exact same thing that we've done for all of the other questions above, and we'll just say that F equals open brackets the name of the file. So this is numbers.txt. Again, remember that extension. If you don't have the full name of the file, you will get an error, which I can show you in a moment. So again, it's going to be quite similar to the previous example here. So we want to loop through each of the lines of the file, which we've just learned to do in question 2. And then we want to continuously add those to an existing number. So again, I can even use the same variable name. So I can say that the count is 0. Actually, let's call this total because that's really what it is. So say the total is 0, and then we're going to say for line in F. So we're going to loop through each of the lines in the file, and then we're going to say we want to add them together. So we'll say total plus equals line. And then obviously the final step we need to do is actually show the result. So we just do a print of total at the end. I will clear this and we'll run that and we'll see what happens. So we're getting an error here. So again, we come down, look at the end of the error. It says unsupported operand types for plus equals, int and string. So this is something, again, to do with casting. So one thing to remember here, when we're dealing with files, everything is always read in as a string, and I can't do mathematical expressions to strings, if you remember. I always have to first of all cast them to an integer. So on here, line will currently equal a string. All we want to do is cast that to be an integer. So now each time we are adding the value of each line, we're obviously making sure that it is a number before adding it. So we'll run that again and we get a result. Hopefully everyone in the chat who did the question got the same sort of answer. But that's gone through and has added every value up in that number file. So I'll just show you an example here. Let's say that we have opened the file and we've just said that it's called numbers and we've not put the extension. So if I were to run that, you see again, I get an error. And we're watching out here for no such file or directory numbers. So without putting the full name of the file, including the extension, you will get that error and that will sort of stop your program at the very start. So it's a common error that you'll get when dealing with files is that you'll just accidentally, you'll write the file name as number.txt and it's quite then difficult to spot that sort of bug. So just watch out for that no such file or directory. And obviously it helpfully tells you what it's looking for. So numbers, and we know that you have to say numbers.txt. Okay, so that is all of section A's questions. Is there any immediate questions in the chat that I can go through over these first questions? Or if not, we'll jump on to section B. So again, if you are getting errors when you run your code, read out those error messages. Try and decipher them. They're usually a lot simpler than they look. I know they oftentimes look quite intimidating there in red, but at the very end of them, there's normally just a string of text that will point you in the right direction. So common errors that you'll get are most likely to be you probably missed off the colon at the end of a for or a loop statement. You might have got your indentation wrong. You might have just mistyped something. You might have not used a closing bracket or a closing quote, double quote mark. So those are some of the common errors, but the error messages really do help you. So try and get used to reading them and trying to decipher what is going on. I know it's very common just to say like, oh, I'm getting an error. I sort of give up. However, the error messages are there to help you. Okay, let's jump on to section B then. So B1, we're going to ask a user to enter their name and we're going to append that to a file called register.txt. So this question now is the first question about having us writing to files. So we've sort of done this question in previous lessons where we will ask people to enter details, but then we just sort of use those details during the execution of the program, and then once the program is finished, we've lost all of those details. So this is our sort of first example of saving information that we could then open up and recall the next time the program ran. So first thing that we'll do here, let's open up the file that we're actually going to write to. So again, the question is giving us those details. So we're just going to say that f equals open, and the name of the file doesn't hugely matter, but let's keep it here with register.txt. And this time it's telling us to open it in the mode to append. So I'm going to say A. So again, read is R, append is A, and if you want to write and to have it eliminate all of the existing content of a file, that would be W. Okay, so we've opened a file and we have the ability to append to it. So the next thing that now we need to do is actually, go through and ask the user to enter some details. So the way that we ask a user is obviously using the input. So let's just say that name equals input, and then we'll ask the question, what is your name? Give them an opportunity to answer that. So again, as we go along, I'm just double checking that the code works here. So we run that, it's opened the file successfully, so that's good. It's asking me to enter my name, and then I'm just printing that out. So at the moment I'm printing that out to the screen. What we need to do though is have that print out into the actual, or sorry, to be written to the file. So instead of printing the name here, we can say the name of the file, so f.write, and then whatever we put now as the parameter here for this function, that can be input into the file. So we should just be able to say that it's f.write and then put the name, and that will then write it to the file. And then the last thing that we like to do with a file, obviously when we are appending or writing to it, is to close it, and that just makes sure that none of the data gets corrupted. So we're going to run that again. So what is your name? Jake. Okay, the program finished. So on the left hand side now, we'll come down to register.txt. And I perhaps should have cleared it before, but you'll see that the first entry in there now is Jake. So let's run that program again now to make sure that the append is working as we expect it. So I'll come down here, I'll put in SAF this time the program runs, run that, it saved it, jump back into the file, and okay. So you see here that it's appended SAF's name to the file, however, it's all put it on the same line, which obviously now we have no way of knowing where one name begins and one name ends. So we'll come back into the code, and all we need to do is we need to just add in a new line. So hopefully everyone remembers this from, I think, our very first lesson, which obviously to use the escape character to add a new line. So I'll run that again. This time we'll put in Sanj, throw that in, we'll come back to the register. Oh, so it's added the name and it's sent us to the new line. So again, we'll come back, we'll run it. The next name, we'll say Tom, put that in, check the file. Now you can see that Tom is on the new line. So again, I can come in here, I can delete the contents of this file. We'll go back, we'll run it. So we'll say Jake, run it for a second time. We'll say SAF. Okay, and then we'll go back and we should see now that we've got our sort of expected result of each person's name on each line. So you could make this this script a little bit more fancy and useful. So in the past we've done this while loop while asking for people's names, and we're just going to keep asking them to enter a name until they don't. So let's just say that name equals true, and then we'll say while name does not equal an empty string. So whilst the user continues to enter some sort of value, we're going to ask them to input their name. We're going to write that to a file. Okay, so we'll run that and we'll see what happens. So what is your name? Jake. Oh, asks me again. We'll put in SAF, and then I'll enter a empty line, and the program ends. Again, that will have just added more items to this file because we're just appending. So now we've got Jake and SAF on more lines. So we'll come down, and what you might have noticed actually at the end of that register is we've now got 2 empty lines. And the reason why we've got 2 empty lines is that when the user on line 40 here enters an empty string, well, that still gets written to the file. So what we can do here is just add some validation. So we can say that if name, so if the user actually enters a name, only at that point do we bother writing to the file. If they don't do that, there's no point. So I'll come back to registers.txt. Let's delete all of that so we're starting fresh. Let's run our program again. We'll put in the usual names and an empty name at the end. And then we'll jump back into our register.txt. As you can see here now, it's sort of what we expected. It's waiting for our content or our next name on line 4. So that's good. We could change this, so we could edit this example now. Instead of being appending, we could do a W for writing. So we'll see here that we've got Jake, Saf, and Tom in that order. If we run our program again, let's put them in the other order. So Tom, Saf, Jake, spell that. And then we'll jump back into register, and you'll see now it's erased the content of that previous file and has just put what we've added in that one execution. So again, if I run that again, and this time, just put Sanj as our only value, next time we go into the register, everything is gone other than that one name that we added. So that's the difference there between using the append and the write. So again, that's one thing to sort of watch out for if you're trying to store data for a longer period of time. Make sure you are appending as opposed to just writing to the file. Okay, question B2. We want to create a new file called even.txt that contains only the even numbers. Okay, so the file numbers.txt, it's the same one that we used earlier. So it says 5,000 numbers. Obviously, it's a complete random set of numbers, and we want to go through each one and figure out whether they are odd or even. So again, this is something that you've done a few times throughout the course, is to use the modulus operand to see if a number is odd or even. So when dealing with files, as always, let's open one up. So fopen. The name of this is even.txt. Again, the name of this doesn't really matter. Obviously, just try and name things appropriately. Obviously, this is a file that contains the even numbers, so it makes sense to call it that. So that follow the same sort of rules as when you're writing variable names. So we're going to do this in write mode because every time that I run this script, I don't want it just to append the same even numbers each time. So I want it to erase the content of the file and just give me whatever the even numbers are. So now that I've got my file, we need to open the other file. So we can do this all in line. So I'll show an example of that. So previously we've been storing the file into a variable, but we also have the option here to say for line in, and then we can actually open the file here. So we can say open the name of the file. So this is numbers.txt. And again, we're just going to open that in read mode. So we'll go through that. Again, we can sort of double check our working and make sure that things are actually doing stuff. So I'm just going to print out the content. So this should show us so that's printed out the entire content of the file. So that's good. So we know now that the line variable contains the number. So we need to, validate that that is correct. So as we had on that previous example, when we read from a file, it gives us in the data type of a string. So the first thing I'm going to do is I'm going to cast it to be an integer. So I'll probably put that into an intermediate variable. So I'm going to say that number equals int. So we're going to cast the value of the line. So now the variable number contains a integer version of the actual number. So now to actually do the check to see if something is odd or even, so we can just say that if number modulus 2, and if that equals 0, it means that there is no remainder. So if the value was 10 and you do modulus 2, there is 0 remainder, and we know that 10 is an even number. So that's what we're looking for. And before I write it to the file, again, I'm just going to do this sort of sanity check as I go along. And I'm just going to print out the number. I'll run it again. Okay, so I'm just taking a look over the results here. I can see that they all look like even numbers to me. We've got ends in 0, 8, 4, 2, 6. Yep, they're all even numbers. So I'm happy that my code is working as expected. So now as the final step, I need to write that to our file. So we've called it f on line 54. So we're going to say that f.write, and we're going to put in the number. So let's see what happens when we just do that. So I'll run the code again. Okay, so now we're getting an error. What's the error? The final line of the error. The right argument must be a string, not an integer. So we casted the number to an integer. So we don't want that. So perhaps instead of writing the number, we could instead just write the line. So I'll run that again. Let's see if we get a different error. Okay, so no errors. So it looks like it should have worked. So we'll jump onto the even.txt file. And as you can see, we now have a file that contains all of those even numbers. So if you got this question yourself, it looks like there are 1,715, so 1,715 even numbers in that file of 5,000. So you could work out there what the number of odd values were also. So that's how we can get the even numbers there. So we've processed a file. So we've opened another file, we've processed it, and then we've stored the results in a different file. So this is a common sort of thing that you do when programming. So it is sort of important to remember this. So one new thing that you might not have seen there, obviously in this example, is just in this for line, where you can actually do that open statement in line. So you don't always have to store it to a variable. Obviously, storing it to a variable then just allows you to reference it later on. So you couldn't do this f.write unless you did, unless you actually assigned it to a variable. Again, as always with these questions, there are multiple ways that you can answer them. So don't feel like if you've not done them exactly the same way that we have, that you've got them wrong. It's more about getting the answer correct. And obviously figuring things out yourself and how you go about breaking down those problems. Okay, so question B3, this is the sort of encryption one. So secret.txt contains a secret message. Each number represents a letter of the alphabet. So if it's a number 1, it equals the A character. If it's number 2, B, etc., all the way up to Z being 26. So we want to work out what the secret message says. So I'll just open up the secret.txt to see what the content is. And so without doing this, obviously I wouldn't know how I'm going to have to write my program. So I'm looking in, every single line has a number. So I know now that I probably need to read through this file line by line and then obviously exchange each of the number representation with a character representation. Okay, so now that I know roughly what we need to do, let's come back. So as always, hopefully you're getting a bit fed up with me saying it, we're going to open the file to begin with. So fopen secret.txt, we're only going to read it, so we'll give it a read mode. I know that I need to loop through the file. So let's say that for line in F, we're going to loop through and let's just print it to begin with. So again, I'm just validating that those 3 lines of code are working. Yep, it prints them all out, so that's good. So now to actually solve the problem. So what we need to do is we need to create some sort of way of referencing a number to a character. So hopefully you picked up in previous lessons a couple of different ways that you can do that. The way that I'm going to do it today is using a dictionary, again, because it's that idea of a key and a value. So if you think of each number as being the key, and then the value is actually going to be the, I guess the character, the letter. So I'm just going to have to set up now a dictionary. So let's do that. So this is probably going to take a little bit of time. This is going to be a bit of sort of grunt work. So I'm going to say that so I'm going to create individual keys for each letter of the alphabet. So this might take me a little bit of time. So we'll go down do each of them. And finally 26. Now I just need to come back and actually add. So again, a lot of this question is going to be based around just setting these things up. So I guess while doing this, are there any questions in the chat that I can sort of go through while I do this? Because this is quite a boring and tedious task. Again, I'm sure that I'm going to make some errors in here. So if anyone in the chat sees any errors, I will watch out for those. JKLM and so it's week 8 this week. Obviously next week will be 9 and then finally week 10. If anybody wants to do the Duke of Edinburgh, PQR, we're also running an additional few sessions after week 10, which will allow people to get that 12-week bronze Duke of Edinburgh award. And again, even if you're not doing the Duke of Edinburgh, but you want some more practical examples, those extras 2 weeks will be really valuable to people. Oops, what have I missed out here? That's Z. 25 is what? Y. It's just X, isn't it? Fingers crossed I've got all of those correct. I'll just run that just to make sure that I've not made any errors. Yep, so we didn't get any errors, so that's good. So now we've got our dictionary. Here we can start to compare the key to the values. So we'll come through here. So my keys are actually numbers in this example here. So I know that I need to cast the value. So I'm just going to say that secret equals integer of the line. So now we've got in the variable secret, we've got just a number that it will be. And then all we have to do is print out whatever the value is within the dictionary. So print alphabet followed by secret. So I'll run that, we'll see how far we get. Okay, so it has definitely gone through and printed something out. Obviously, it's a little bit difficult to read because it's over multiple lines. So again, just to fix that, we'll just say, we'll create another variable called word at the top. And then instead of printing it out each time, we are just going to add it on. So we'll say that word equals what? Word plus whatever our letter is. And then as the final step, I guess it might not even be a word, it might be a message, but again, we can come back in and change that. So I'll run that. Okay, so you'll notice here, obviously, that spaces weren't included, but the message says, congratulations, code breaker, you now know Python. So hopefully people got that. But as you can see here, you could do this for any sort of encryption. All that you would need to do here is change whatever the key and value is. And this is the basis of how a lot of encryption works. It's just replacing values, and you can get more complex. Obviously, you could have it change after each time you encrypted a letter so that these things moved around, as long as you can do it both ways, in that you can encrypt and decrypt. So you have to follow the same set of rules each time. But this is a very basic way that you can encrypt messages. You could just say actually that, well, actually, the number 1 references J instead, and you could go down and you could provide your own sort of key set to obviously encrypt any sort of messages that you wanted. So we'll just comment that one out, and I think then we're on to the final Yeah, the final question. So I'm interested, first of all, in the chat. Did anybody manage to complete question 4? It'd be interesting to see. So this is it's definitely a harder question than we've given you before. It requires you to do a lot of things. Awesome, looks like I'm getting a lot of yeses in the chat. Someone wants to see the end of question 3 quickly. So once you've got your dictionary set up in question 3, it's all just about going through each of the lines of the code and referencing whatever the value is. So secret equals a key that references a particular letter in the dictionary. Okay, so let's just go through the question first of all to make sure that people understand it. So Benford's law states that the leading digit in a collection of data are probably going to be small. For example, most numbers in a set, and this is realistic, about 30%, will have a leading digit of 1, when the expected probability is 11.1. AKA 1 out of 9 digits. So if your data is completely random and fake, it's likely that the leading digits that you produce will obviously be spread out evenly over all of the numbers from 1 to 9. Obviously, we don't care about 10 because 10 begins with a 1, and the 0, in the way that we do maths, obviously we remove the 0. So there's only 9 possible options. So 100 divided by 9, that's where you get your 11.1%. Fake data is usually evenly distributed, where the real data isn't. So we've provided some files here. So I think there's 3 or 4 of them. 3, yeah. So accounts 1, accounts 2, accounts 3. They contain some sort of financial transaction data, and we want you to go through and tell us which of these files contains fake data. So again, it's a lot of information in each of these files. There's, let's see, is it 10,000? Looks to be 10,000 records in each file. So again, it's something that you can't really do manually, and this shows you where programming is really beneficial. So what I'm going to start off first of all is I'm just going to try and do it in one file. So I'll start off and I'll just see the results for, let's say, accounts _1. So first thing that we're going to do is we're going to open the file. So let's open accounts _1.txt, and we are reading it. Okay, so then what we're probably going to do here is we're going to loop through the file. So for, let's say, line in F, and as always, I'm just going to print that out just to make sure that I've got the file name correct. Okay, so we've shown all that data. So one thing that we need to watch out for here is obviously this is financial data. So if we did cast it to an integer, we might actually lose some important information if we were also going to be processing it for different things. Okay, so now the next thing that we need to do now that we can actually read the file is that we somehow need to get the first digit of all of these numbers. So hopefully you recall from previous lessons the indexing ability that we have. So what we can do is we can just get the actual index. So line square brackets 0, and that should give us the first, we'll call it a character at the moment because we know that it's a string. Has that actually printed it out? I can't see if it's... This is where REPLs... Oh, there you go. Finally printed it out here. So we've managed to print out the first digit of each of these words. However, it is still a string at the moment. So that's the sort of thing that we need to go through. So now we actually need to count what these are. So again, the easiest way to count things like this, it's probably just by using a dictionary. So again, I'll create a new dictionary, I'll call it count, and within that I'm going to set up individual keys for each of them. So this time I'm going to do it as a string. You can still do it as an integer. So the actual key here is going to be the string value of 1, and that's just because I can't be bothered to cast it down here to be an integer. So we'll keep it there as a string, and it also shows you something slightly different from the previous example. So all I'm doing here is I'm creating the dictionary that will contain the counts. Obviously, to begin with, all of these values will be set to 0 because we don't know how many there are. So I'll just go through, do that for each of them. So again, you could do this with a list. You can do it with a count, but use integers. There are lots of different ways you can do this, but all you need to be able to do is somehow store information about each of the potential leading digits. So there we go. We've got our dictionary now that contains different keys for each of the potential values. So instead of printing out down here now, I want to actually count the number of them. So in here, we're going to say that count, and then we're going to reference an individual key. So the key that we're going to reference is going to be that first character of whatever. Oh, that's not good. Hopefully we've just not lost all of that code. Right, where have we got to here? Count, we've got our dictionary set up, we've got count here. Yeah, so we're going to basically increase this value every time that it sees a number that starts with that character by 1. So I'll do that, and then just to check that it's actually doing something, we'll print out the dictionary count at the very end. So we'll run that and we'll see what happens. Okay, so we can see that it's definitely counting stuff here. So we've got the actual number of things. So in this file, there are 3,245 entries that start with the number 1. So we could sort of leave it at that point there, but I think we should make it a little bit more fancy. So what we're going to do now is we'll go through each of them and we'll sort of print out the percentage. So thankfully, each of these files has 10,000 numbers. So that means that we can just divide it by 100 to get a percentage. So we'll come down, so instead of just printing that out, let's do what? Let's loop through. So we're just going to say that for, what should we say? For x in the range of 1 to 10, I'm going to print. Do we want to print? Yeah, I guess we do just want to print. We will print out the string value of x. So that's going to be like 1, 2, 3, 4, 5, etc. We'll do that. Let's run again. Let's just make sure that my logic's correct. Okay, so we've got now a list of our digits 1 to 9. So on here, we just need to start building up our input. So we'll add a equal signs, and then let's do what? So then we need to actually work out the value for each of these. So it's stored in count, so we're referencing our dictionary. We need to then reference our individual number within the dictionary. However, since the keys in our dictionary are a string and we've only got x here as an integer, we need to obviously convert that. So we're going to get string x. So I'll run that and make sure that that is working. Oh, we can't concatenate a integer to a string. So count here is providing a integer. So run that. Again, this sort of shows that importance of checking each time you do something. Because if you sort of moved on there, you would have had that same bug when you ran your code, but you would have no idea where you actually introduced the bug. So now I've got a display of 1 to 9 and it's showing me the count. We, however, want the percentage of this. So as we said before, we know that there are 1,000. So if we divide it by 100, let's run that again. So now we're getting close to our percentages. To make this look pretty, let's actually add that on the end. Okay. So there we have code that will go through and give us a percentage for each of them. But at the moment, obviously, we're only checking file 1. So if we just go back up and look at what Benford's law state, if it does follow Benford's law, we would expect that the smallest example would be about 30%. So here, this to me looks like it does follow Benford's law as you go down the digits. Obviously, 9. All the numbers that start with 9, you only got almost 4%, whereas the digit starting with 1, you've got over 30%. So that does look like it does it. So let's go on and let's see how we can obviously check it for the other files. So what you could do is obviously you could just copy all this code again and paste it, but then obviously that doesn't follow our dry principle. So we don't really want to do that. You could just say, well, I'm going to change the file name. So that's another option here. But then, again, that just means that every time you want to check a different file, you would need to edit your code there. So that's not, a fantastic way of doing it. So when I look through here and I see the name of the files, all of the files follow the same naming convention. So it's accounts underscore and then a number. So that immediately screams out to me that I have the ability here that I could actually loop over the files. So let's do that and see what happens. So we need all of this information in the same place. So just for clarity's sake, I'm going to move this count just below the file open, because then at the start, the first thing that we'll do is open the file. So in order to loop through these 3 files, it sounds like a perfect example to use a for loop. So here we're going to just say that for, what variable have we not used? We've not used y. We've used x further down, unfortunately. We'll perhaps come back and rename these values shortly. So for y in, what should we do? We do a range of, what will it be? 1 to 4. So we don't want it including 4. We only want it to go up to 3 because those are the files. So now within all of this code, so I'm going to indent everything inside this for loop. So if I could highlight all of that. Okay, so all of our code now is going to be repeated within our for loop. And the only thing that we need to change is actually this 1 here that's in the file name. And as we know, we've got it currently stored in our variable y. So with file names, you can also concatenate, so just like any other string. So instead of hard coding the name of the file, I can say that. So let's run that, see if we get any errors. Okay, so again, we're getting an error here. Look at the error message. You can only concatenate a string, not an integer. So this is telling me here that y is an integer. It needs to be a string. So we'll do that. We'll run the code again. And as you can see now, it's showing us the results for each of them. So before we actually delve into that, let's make it look a little bit prettier. So because we don't know at the moment sort of what file we are referencing, we can just add in a statement here that will be printing the name of the file. So I'm just going to copy that at the moment. So I'll copy that, run it again. So let me close that. Okay, so now we've got a little title that says we are processing accounts 1. This is the results that we've seen already. So we've got 30% going down to 3%. Accounts 2, they're all very, very close to 11%. So that sort of indicates to me that accounts 2 is random data that somebody has made up. And accounts 3, again, it sort of follows this distribution of the lower digits being used a lot more. So here, for the answer for this question, obviously accounts 2 is the fake data. Someone has clearly gone through and just used the random function to generate 10,000 random digits. So that's the answer to this question. We're now going to spend a little bit of time refactoring this, because whilst the code works, we can make it a lot cleaner. And this is a really good example of showing you this. So the first thing that's sort of screaming out to me here is that I just copy and pasted this exact same line over multiple lines of code. Obviously, again, that should scream out to you, don't repeat yourself. So instead of doing that, what I'm going to change first of all here is we'll create a variable, we'll call it file name, and within that we will then do the concatenation to work out the file name, and then wherever we use that value, we'll use the variable instead. So right there, if I happen to change the name of the file name to something different, I now only have to change it in one location, and it will do that. Again, when I'm refactoring, I'm going to always keep running my code just to prove that I've not broken anything. So we get the exact same results there. Let's see how else we can do this. So obviously we learnt in week 7 about functions. And again, this would be a perfect example of somewhere that we could use a function to calculate this sort of stuff. So let's think about how we could put this into a function. So let's start by defining one. So we're going to define our function. What's it? It's Benford calc. So we're going to create a function called Benford's calc or Benford calc. For that, what should we do? Should we pass in the name of the file? So let's say that file name is going to be our parameter that we pass in. And then, so I'm just going to come down now and sort of delete our previous code. So we're not going to need to loop through anymore because we've got a function. So let's just delete that. We don't need this file name because we're passing in the name of the file to the function. So I'm also going to delete that. So our function, the first thing it's going to do is it's going to open the file name that we're passing in. It's then going to print the name of it. It's going to calculate the stuff, and it's going to print out the results. So if I run that again, I expect to see nothing. So that was the old. To run that, there's no output because now all of my code is inside a function, and the functions don't run until we actually call it. So underneath here, I'm going to call the function. So what was it called? Benford calc. And we can pass in a file name. So again, we'll start off just by passing in one file name. And then let's see if that works. Okay, so I can now call a function called Benford underscore calc with any file name, and it'll give me the results. So I can do 1, I can do 2, etc. So again, hopefully now you're thinking to yourself, I'm just going to paste in that I saved earlier. Just ignore that. It's just saving me. I knew I'd need it later. So obviously we need to run this function multiple times. So you'd start off by doing this. Okay, so now you're running that function 3 times, but again, it should be screaming out to you, oh, we're doing something that is repeated. What happens if the name of the function changes? So again, we're going to come back in here and we're going to say for x in a range of 1 to 4. We'll do that. I'm going to bring in my file name code that I just pasted above. So the first thing that we're going to do in this for loop is work out the name of the file name. That now needs to be an X. And then instead of calling this 3 times, what we're going to do is just pass in the file name that we have. So I run that code again. It runs it for each of the file names, which is perfect. You see, we get the exact same result, but now anybody can use that to call this function with a file name. So the next way that we can refactor this, we should be a little bit wary when we're doing things like opening files within a function here. Because what happens if I just had some data that I wanted checking, and I didn't have it in a file, or it was in a different format, or I didn't want to do certain things. So again, we should be thinking of functions as accepting some form of data and processing it, and also doing a single job. So what I'm now going to do is I'm actually going to create another function that will accept a file name, and I'm going to edit this Benford's calc to actually accept a set of raw data, so a list of data, and that will then give me the opportunity to be able to provide any list of numbers to this function, and it will tell me if it passes Benford's law or not. So the first thing I can do here is I'm just going to copy and paste. So a lot of refactoring is that sort of copying and paste. It's just going through and tweaking your code slightly. So I'm going to say Benford underscore calc underscore file. So I'm going to create a new function here that is only going to accept a file name. And the only thing that this function needs to do is it needs to open the file and read the content. So I'm going to copy that line that we had before. So we've got f equals open, we're opening the file name. And then what we can have this do is it can just call this other function that we're going to change in a moment. So Benford's calc, we'll call that and we'll pass in the content of the file. So we'll pass in f. Okay, so f is a list that we can loop through. So now let's edit Benford's calc, and this time we want to accept some sort of data. So we no longer have to open a file in here, and we no longer have to print a file name because we don't know if it belongs to a file name. The only thing now that Benford calc is going to do is go through and actually count the values. So we'll come down here, so data, all we need to do is change f to data. So we're passing in a list of numbers, and then we're going to loop through each of those numbers, and we're going to do the same process again. Okay, so I've made quite a lot of changes there, so I want to think about now how I can actually start to check that this is working. So I'm coming back down here. I no longer want to call Benford underscore calc. I want to call Benford underscore calc file, and I'm going to pass in the file name. So what's going to happen is the script will come down here. We're going to loop through each of the file names. We're going to call this one function. That's going to come up here. That opens the file. It gets the data from the file, and then it calls our one function, and it passes in the list of data, and then it calculates it based on that data. So we'll run that. We get the same results. At this moment, it's not printing out the file name because, again, we took that out. So let's add a print line here, file name. We will run that. I wish I said it would clear each time. Run that, we're getting the exact same results. However, now we've made two functions, and we have one called Benford calc here that we can use to pass in any sort of data. So let's come down to the bottom. Instead of going through our individual files here, I'm just going to comment that code out. And I'm going to call Benford calc, and I'm just going to pass in some data. So it needs to be in a list format. So if I just pass in, 1, 10, 30, 55, let's just pass in a few numbers and see what happens. Okay, so it's saying here the int object is not scriptable. So the problem here is that a file that we were getting had all the values in as strings, and yet we're passing in integers here. So the simple thing that we can do just to check that this is working quickly is instead of passing in numbers, we could just pass in strings. So that could be sort of step 1. So run that again. Hopefully, if REPL catches up with us. There we go. So of those numbers that I've just put in there, again, so unfortunately at the moment, because we divide by 100, we're expecting 10,000 characters, but that would be the sort of next thing that we'd go through. But as you can see now, we've made a function, the Benford underscore calc, that can accept a list of data. So it doesn't matter where you get it from. You can get it from a file. You could produce it elsewhere. And we can pass that in, and then we could start to go through here and obviously just adjust this percentage. We need to count the number of records that we were going through, and then divide by that to make it appropriate. But hopefully you sort of get the idea there. We're running to the end of our time, but this is just to show you the idea of this function here, the Benford underscore calc underscore file, does a specific job. It runs the Benford calculations on a file, whereas we've then created one that will just run it on any data. So anybody can call this function with any set of data, and the file function becomes very simplistic because all it has to do is open the file and get it in a format that your calc function can actually handle. So again, it makes all of these functions a lot more reusable. And I think we do have some more code examples of sort of further going through and refining this code. But we've come to the end of our time today. So as always, hopefully Saf's been answering your questions live in the chat. If you've got any further questions throughout the week, please ask them on Slido using the code Python 2020. Obviously, Saf goes through those and answers them every day or so. So if you are struggling, please do just ask questions on there. And our next session, lesson 9, is next Tuesday. I believe that's the 7th of July. Usual time, usual place, 10 a.m. And we will see you then.